Hello, this is day 10 of our daily Putnam challenge. 10 days of incline push up, and yeah, I can feel the biceps, man. So from all the push up, it would be nice if there's like also an indicator of your improvement when you're trying to solve mathematics. Like imagine if you have like some abs on your forehead just to show people how monster you are when it comes to mathematics. But of course, we don't live in such a universe. You only get indication when you do physical practice. But anyway, let's do this first. Five incline push up. One, two, three, four, five. Yeah. So let's write down our progress. Five push up. So the question is from Putnam 1998. Find the minimum value of quantity x plus 1 over x to the sixth minus quantity x to the sixth plus 1 over x to the sixth minus 2 all over quantity x plus 1 over x cubed plus quantity x cubed plus 1 over x cubed. Okay. This looks simple enough. So let's add five more. 6, 7, 8, 9, 10. Okay, so let's write here 10. So the first thing I'm saying, so we want our x to be greater than 0. So let's write the whole thing as f of x. So one of the things that I can do is, you see in the denominator, some terms in the denominator looks like the terms in the numerator. So one of the things we can do is, let's call this whole term right here, I don't know, y, and then let's this whole other term right here as z. Okay, so that now we can write our whole function as so you have y squared, because your y is x over x plus 1 over x cube. Okay, so x plus 1 over x to the 6 is just y squared minus, let's combine all these things. You have x to the 6 plus 1 over x to the 6 plus 2. Okay, and of course in your denominator you have 1 plus z. Of course, the second term in the numerator, x to the 6 plus 1 over x to the 6 plus 2 is nothing but, okay, this whole thing. Okay, this whole thing in our numerator, this is nothing but x cubed plus 1 over x cubed squared, correct? So if you expand this particular term right here, you get the second term in the numerator. Okay, so now we can write our expression as y squared minus z squared over y plus z. Okay, 11, 12, 13, 14, 15. Okay, so what do we do next? Well, the numerator, you can factor that out as y plus z, y minus z over y plus z. So of course, this term cancels, so you are left with y minus z. So in other words, our f of x is simply, what was our y again? X cubed, x plus 1 over x cubed, and then minus our z, which is x cubed plus 1 over x cubed. Okay, so we're now at 15, 16, 17, 18, 19, 20. Okay, so let's write our 20 over here. So let's just expand the first term here. So you have x cubed plus, so from the binomial theorem, you have 3 times the square of the first times the last term. So you have 3x squared over x, that's just 3x plus, so you have 3 times the first term times the square of the second term. So you have 3 over x, okay, plus 1 over x cubed, right? And then you have minus x cubed minus 1 over x cubed. So this term will cancel with this term will cancel with this term. So our f of x is just 3x plus, so let's write it here again, 3x plus 3 over x. we want to find the minimum, okay? So to do that, to get the minimum or maximum, in other words, the extremum, we integrate, sorry, not integrate, we get the derivative of our function. So that's just 3x, what's this, minus 3 over x squared. Okay, sorry, not 3x. I'm an idiot, just 3 because we're taking the derivative. And what you do is, to get the extremum, you set f of x equals 0, okay? So that implies that our 3 over x squared is equal to 3, which implies that x is equal to plus equal to 1. But note that we want our x to be greater than 0, okay? So therefore, we take x equals 1, okay? X equals 1, does this give you a maximum or a minimum? So what we do in order to check that is we get the second derivative, okay? F of second derivative is just equal to negative, what's this? uh, no, not negative. This is now positive, and then this will give you 6 over x cubed, okay? So that our f prime of f double prime of 1 is a positive number, is greater than 0. Therefore, okay, therefore f of 1 in the original function is minimum, okay? Because f the second derivative is positive, okay, and that minimum value is minimum, and that value is in particular is equal to, so we substitute it to 3 times 1 plus 3 over 1, which is basically this one right here, okay, the one that I'm boxing. We substitute it there. That should give you 6, okay? So 6 is the minimum value of that particular complicated function, which became simpler once we recognize that some of the terms in the denominator looks like the ones in the numerator. Okay, so let's finish the push-up as well. 21, 22, 23, 24, 25. Okay, so we have 25. So that's it. A very straightforward problem. Again, from Putnam 1998. Thanks for watching, guys. This has been day 10. I'll see you next time, and bye-bye.